Today we're going to look at images of peripheral blood and a little bit about hematopoiesis. We'll talk about the cells of blood, the red blood cells, the white blood cells, how to identify the different cells, and how they may look in tissue. Then we'll talk about bone marrow, the different cells from the immature to the mature cell, or vice versa, from the mature to the immature cell, to be able to look at the characteristics of both the nucleus and the cytoplasm and how it changes with development. Thank you. Today we're going to talk about peripheral blood and hematopoiesis. If we look at whole blood, we see red blood cells and we see white blood cells. So let's just take a look at that and we'll see. Here we see white blood cells. Here these are neutrophils. I'm going to go a little higher mag of that. See neutrophils, platelets. These are red blood cells. More neutrophil, neutrophils, maybe a lymphocyte over through there. So we have white blood cells, which are these blue ones, and we also have red blood cells in here as well. So if we take a look at these, we can see that of the white blood cells there are different types. There's types with granules and types with no granules. The types with granules are the neutrophil, which has very small granules, eosinophil, fairly large granules, and basophils, fairly large granules. These would be blue granules, and these would be kind of orange or red granules in the eosinophil. These are the ones that have granules. The other ones without granules are the lymphocyte, the monocyte, which gives rise to the macrophage, and we can see the kind of horseshoe shape and a lot of cytoplasm and a euchromatic nucleus characteristic of the monocyte. So if we look at some of these in real cells, we can see an eosinophil here, a lobulated nucleus with different lobes. It's the same nucleus, it's just different lobes. And we can see the granules. And here we see a neutrophil with various lobes, small granules, and a basophil. The nucleus, the granules, the nucleus is below, but you see some granules on top. It's hard to see the nucleus. It's hard to see the distinct nucleus in a basophil like you can an eosinophil or a neutrophil, because the granules do not lay out to the side whenever the cell does not flatten like these guys do. Also the monocyte, which is a more euchromatic nucleus, not so dark, more lighter nucleus, and maybe horseshoe shape and a lot of cytoplasm. And then the lymphocyte. Here's a nucleus from there to there and a little bit of cytoplasm that we have there. So basically these are neutrophil, eosinophil, basophil, lymphocyte, and monocytes is what we have. So if we take a look at blood, we can see what they do. In case of bacterial or fungus infection, you have a lot of neutrophils. Eosinophils, where you have a parasitic or allergic response. And basophils, where you have histamine and inflammatory response. Lymphocytes can be either T or B lymphocytes. They can make killer cells or they can make plasma cells, as we'll talk about. And then we have monocytes. These monocytes are transient cells in the blood. They go from the bone marrow to the tissue where they will become either fixed or migrating macrophages in the body. And so if we look at slide 21, we can see lymphocyte. This is a nucleus from here to here and a little bit of cytoplasm and a fairly spherical nucleus we see, as opposed to the eosinophil, a lobulated nucleus and big granules, red granules. Here's a monocyte with a kind of horseshoe-shaped nucleus and a lot of cytoplasm, kind of large like eosinophil. And then the neutrophil, which has granules in there but very small. And then we have the basophil, we have the granules above the nucleus. And the other non-nucleated thing, in addition to the red blood cells are non-nucleated, you also have the platelets. And here we see the platelets in there as well. So if we look at slide 51 for neutrophils, we will see them. Slide 51, we see those. Here we see some neutrophils, one here, one there, and these are platelets, and these are white blood cells. There's another, probably, I'm not sure what that is, but you can't identify them all. More neutrophils we see. There's a lymphocyte and a neutrophil. There's a reticulocyte below there, which is a blue side of blue tint. There's another reticulocyte through there and a neutrophil that we can see. So if we go back to this, and we see that neutrophil has granules, but they're smaller granules. These are small granules. These are mitochondria. So these are smaller. The granules are smaller than the mitochondria are themselves. And so we can't see distinct granules, but you see a lobulated nucleus. So this is part of the nucleus, part of the nucleus, part of the nucleus. It's all one nucleus, but it's got different lobes to it. In addition to the lymphocytes, we have monocytes. And here we have monocyte here and another one there. They vary in shape. Euchromatic nucleus, a lot of cytoplasm associated with them. So if we would look at the monocytes here, let's see, 1, 2, 3, 4, 5. If we would look at this one, we can see a monocyte in through there, kind of horseshoe-shaped nucleus with cytoplasm in through there, and then there's a neutrophil, a little bit larger than a neutrophil. So we can see these. Always, once you find these, go to a lower magnification. There's a lymphocyte, lymphocyte, neutrophil, 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 monocyte. So go and see what they look like at a low mag. Just scroll down to be able to see what they look like. And so if we go back, we can see the monocyte, and then we can see the lymphocytes. So here's a lymphocyte in through there with a big portion of the cell is a nucleus, but it's a small cell. A little bit of cytoplasm. Here we can see the nucleus and the cytoplasm. These are red blood cells, so a little bit larger than a red blood cell. Here's one with carbon replica transmission electron microscopy. Shows you the outer P face of the plasma membrane, the nuclear envelope, the nuclear pores, and you can see that the nucleus is a very big percentage of the cells, as we just indicated. Now those lymphocytes, as we see one here and one here, could be T or B. If they're T cells, they become active, and it could be helper cells, it could be memory cells, but they also could be cytotoxic killer cells. So T cells become the killer cells that actually kill things, as opposed to the B cells, which become plasma cells. So these transform into plasma cells. You see the spherical nucleus, the cartwheel nucleus shape that you see here. Here's another one in through there. A lot of cytoplasm in the spherical nucleus is your plasma cells. And here we can see those cartwheel nucleus here. Cytoplasm go around here, and this cytoplasm has lots of rough endoplasmic reticulum in it because it's making antibodies. Here you can see your cartwheel nucleus. There's your spokes, the hub of the wheel. So the next cell is the eosinophil, and if we look at the eosinophil, we could see that it has a lobulated nucleus and it has granules, and these granules have a crystalline core. They're a crystalline structure, crystal, inside the granules itself. And you can see they're quite a bit larger than the mitochondria are. And so you can see these eosinophilic granules, or the eosinophils. And if you look at those, again, you can see the big granules, the lobulated nucleus, and you can see here the crystalline structure. So this is the same nucleus, it's just lobed. So if we look at one of those eosinophils, we can see one here in slide 21. This is a eosinophil, and so we want to take a look at that one. Eosinophil is, so here I think we can see, yeah, here's the eosinophil, and you can see the blue nucleus, and you can see the granules out there. Again, look at low magnification. You can see that's a neutrophil, these are lymphocytes, and there with the granules, darker granules, there is the eosinophil. So you can just kind of look around and look for those to be able to find those. And so if we look at the next cell is a basophil, and the basophil, as I mentioned to you, it's hard to see the nucleus on a whole mount, this is not a whole mount. This is actually a section. This is a transmission electron microscopic view showing you there's no crystalline in these granules, but the granules are quite big. And they're varied in intensity, which is a little bit characteristic of these basophilic cells. And so if we look at these again, this is a basophil with the granules, dark blue granules, and the granules are big, kind of like what you see in the eosinophil, except they're blue, not. And so if we take a look at this specimen, we can see the basophil. Okay, here we go. This looks like a basophil with the granules in through there. It's hard to see the nucleus that we can see. Let's see if we can find another. There's a lymphocyte. And so what you see is hard to see the nucleus and distinct granules that we see there. So the basophil that we can see again has these granules like this and granules that throughout the cytoplasm. So in terms of summary, we have neutrophils. There's more neutrophils. We have lymphocytes. We have monocytes with a lot of cytoplasm. Lymphocytes, more red blood cells, erythrocytes, more, and platelets. So these little dots in through here are platelets that we can see. And of course these cells come from bone marrow, and so we see the bone marrow in through here. This is slide 17. Again, we can see the bone marrow, and we see the megakaryocytes, which gives rise to the platelets. So if we take a look at that slide, we can see the bone marrow, the megakaryocytes, and the host of different cells. You can see some lobulated nucleus of these granulocytic series. You might be able to see some round cells that's going to make red blood cells. And so a good place to look is right here on this slide. And you can see there's granules in the cell, megakaryocytes in through there. You can see some eosinophilic ones that are developing along the way. Now, not the ones on the edge, they're bone cells, so it's in the marrow itself, in between the spicules of bone. And so we can see those. Here's another one that we can see. This is in the bone marrow, so this is cartilage in through there, and then this is spongy bone. You can see the spicule bone in through there, the osteoblast along the side. Here's actually osteoclast, which eats up bone. And then this is a blood vessel. So these are red blood cells in the bone marrow, and these are white blood cells. Here you see a neutrophil. You can see the different lobes in through there as well. So if you go to this website here, I know it's long, but if you go to that one, you'll be able to see that slide. So you could go to that website right there to be able to see this slide, which will show you where it has blood vessels in between the spicules of bone and a host of cells being developed there. So if we take a look at that, anyhow, here we can see there's a blood vessel right in through there. There's another neutrophil, different one what we see, another white blood cell. These are red blood cells. This one is a lymphocyte that's in the blood itself, as opposed to these granules here, and there, and there. These cells are immature cells that are being developed in the bone marrow. We can see these dark cells in through there, like these, with dark nuclei, and sometimes have no nuclei. Those are from the red blood cell series, but from the granulocyte series, you can see the big granules located in through there. And so that's what you can see in the bone marrow as a source of these cells. So if we look at the bone marrow, we can see the different types of cells that make a red blood cell. Red blood cell in the adult mammal does not have a nuclei. It does in the fetus, but not in the adult. And here you can see the host of cells that give rise to it. It had a nucleus in the beginning, and so you have a proerythroblast, a basophilic, polychromatic, orthochromatic, and then the nucleus is popped out, and then you have reticulocyte, and then you have erythrocyte. And so here's a scheme of things. You can see that blue, dark blue cytoplasm in through your spherical nucleus. So the first thing is the nucleus spherical oval. If it's spherical, it's in the red blood cell series. And then the nucleus becomes somewhat fractured, but still the cytoplasm is still dark blue. And then in the polychromatic, you've got a light and dark, more than one color. And the nucleus is getting more fractured. And then more fracturing, and the nucleus is going to be popped out like that. And then you've got a reticulocyte. Reticulocytes, the blue cells, and then the red blood cells are your erythrocytes. So if we look at blood, we can see red blood cells. We can also see reticulocytes, but we don't see the bone marrow cells. So whenever we start looking at erythropoiesis, or maybe we should start with what we can see. We know the red blood cell has no nucleus and red cytoplasm. Reticulocyte has no nucleus and bluish tint to the cytoplasm. Orthochromatic erythroblast has a dark nucleus, small, just about to be kicked out, but its cytoplasm is very similar, gray in cytoplasm, very similar to what we see in the reticulocytes. And then the polychromatic, you got more than one color, and you got a more euchromatic nucleus. And then the next younger one, you still got a fractured face, but a darker cytoplasm and less polychromatic staining. And then in the proerythroblast, you have a more homogeneous nucleus, not fractured, not got lights and darks, and a thin blue rim of cytoplasm, uniform. So those start with what you know, and then back up to the youngest form. And so if we start with what we know red blood cells, and that's got hemoglobin in it. And this is what we see. And then the reticulocytes have some ribosomes in there as well. And here we see the ortho. They have some ribosomes in there as well, still persisting. And then if you get the polychromatic, you get the colors from the different colors because you got a host of ribosomes and a host of hemoglobin. So you got both red and blue in through there. And then the basophilic and the promyelocyte, normoblasts is going to have a lot of ribosomes, hence that blue cytoplasm, and a very euchromatic nucleus. So what's changing is it has a nucleus with the immature form, and the nucleus becomes darkened before it's ultimately removed from there. And here we can see a scale. This is the amount of RNA, so there's RNA in these ribosomes, get less and less as you go, and then as maturation you get more hemoglobin. So as you get more hemoglobin, it gets more red and less blue, and that's basically what we're seeing. And if we look at the bone marrow slide that I told you about before, here we can see a red blood cell squeezing through from the extravascular space into the blood vessel, squeezing through, and that's really not a red blood cell, it's a reticulocyte that comes through. So if we look at erythropoiesis, we start out with the red blood cells, reticulocytes, and then the orthochromatic erythroblast, with the nucleus is just about to be popped out, and a very dark nucleus. Then polychromatic, you got different colors in the cytoplasm, fractured face, and then basophilic fractured face with a blue cytoplasm, and then a smooth face with the polyerythroblast. So here we start with what we know. There's platelets that we see there. There's also erythrocytes. Then we have reticulocytes is the next younger one. The next younger one is orthochromatic erythroblast. Late polychromatic, so you got different colors, but it's small, just about to be popped out. And polychromatic erythroblast, different colors in the cytoplasm, fractured face. And then the basophilic fractured face, blue cytoplasm, and then the promyeloblast, as you see here, smooth face, dark rim cytoplasm, and a larger nucleus. So if we take a look at that specimen here, we can see the different things. Is it oval nucleus or is it spherical? That's the first thing you want to name, because this is going to be in the red blood cell series, and that's going to be in the white blood cell series. So if we look at these, we can look. There's an orthochromatic erythroblast, 1, 2 there. Maybe a late poly that we have the ortho. There's a poly for sure. You can see the blue and the red, and through there, another poly through there. But these here are from the Granulocyte series that we can see. And so if we look at the Granulocyte series, you see the first one doesn't have granules, but then the promyelocyte has some granules in through there, and you start picking up specific granules in a myelocyte and a metamyelocyte. And then you got a stab cell, and so we see those. So this is the cytoplasm with just some granules, kind of bluish, but you also have some granules in through there, and then you pick up more granular cytoplasm becomes gray, the nucleus becomes sickle shape, and then becomes lobulated for the complete. So you got the nucleus becomes condensation, as you see, and it becomes lobulated, and the cytoplasm goes from blue to mostly granules in the process. Again, what we see in blood are the red blood cells and the neutrophils. We see those, and sometimes we see a stab cell, which is when it's horseshoe shaped if you have an infection. So why not start with the most advanced cell? Here's a neutrophil, lobulated, dark nucleus, kind of gray cytoplasm, small granules. Neutrophilic band or stab cells, which has a less developed nucleus, less lobulated, more horseshoe shape. And then you have the neutrophilic metamyelocyte, and we can see it here with the cytoplasm there. And then less of a C that we have here for the band cell, the metamyelocyte. And then you got the myelocyte, you got blue and the other granules, and then the promyelocyte, you have just eosinophilic granules located in through there. So here with neutrophilic myelocyte that we can see, that's what this is, an immature myelocyte, basically is what that is. And then here's a neutrophil. So this is a neutrophil here. You can see some eosinophilic granules as well as some dumbbell shape of the specific granules in a neutrophil. And the reticulocyte that we can see here, the kind of bluish as opposed to the red that we see. So if we look at the series, start with the most advanced, you got the neutrophils, the lobulated nucleus, and the kind of gray cytoplasm with very small granules. And then you got the band cell with the kind of sickle shape you see. You got the metamyelocyte that looks somewhat horseshoe, but not much horseshoe as you do in the sickle cell. And then here in the myelocyte, you've got the blue and kind of other granules as well. And then in the promyelocytes, you have bluer cytoplasm, eosinophilic granules in there. A lot of cytoplasm compared to the red blood cell series, and the nucleus is oval. So if you start with what you know and back up with how the nucleus is changing, and then how the cytoplasm is changing. Remember that the more immature cytoplasm is going to be bluish because it has to make something. It has to have the machinery, which is the ribosome, to do something. Also, in the immature cytoplasm, you have a more euchromatic nucleus because it doesn't know if it's going to be a fireman or a dentist or a doctor or a policeman yet. So it needs to have all the DNA for all the jobs it could possibly do to be ready to be unwound. Later on, when it gets more differentiated, it starts shutting down those things. It's only going to be a policeman maybe. All those other ones are kind of shut down, and so you don't need it anymore. So you have to be more flexible at a younger state, and you become more differentiated. You have less flexibility, but you're concentrated on the main function that you have. So over here we see a neutrophil, platelets. This is the eosinophil, basophil, I'm not sure, probably eosinophil. This is a neutrophilic metamyelocyte, as we see there and there, there and there. And then this neutrophilic myelocyte that you see here. Note a lot of cytoplasm, a non-spherical nucleus. And you got the bluish and eosinophilic granules as well as specific granules. And so if we look at that again, we can see the granulocytic series. There's a neutrophil, stab cell or band cell, another one. There's a eosinophil or basophil, I'm not sure. This would be your myelocyte, and then maybe metamyelocyte with a different granules. There is a red blood cell series. This is your stab cell, maybe a myelocyte in through there, more immature myelocyte, as you see with the blue cytoplasm, orthochromatic normoblasts, as you see there, or orthochromatic erythroblasts, I should say. Maybe Eosinophil being a stab cell, another stab cell in through there. So those are the cells that we can see in the bone marrow itself. And so if you expect to find these cells wherever you have infection, here's a chronic infection. You can see all the lymphocytes in through there. And down here we can see there's a host of plasma cells. So these are lymphocytes have given rise to plasma cells, and you can see the cytoplasm associated with it. And here you can see in the blood vessels there's a little venule, or maybe a venule, where you have leakage, margination. So these guys are marginating in through there. And if you look at that, you can see that there's some eosinophils as well as neutrophils. So here you can see the granules, here you can't see the granules. Granules, no granules that we see. So if we look at this slide 140, we can see this is the 140. We can see this is the same blood vessel. You can see the eosinophils and the neutrophil. Eosinophil, neutrophil. These are arterioles in through there, and then these guys are plasma cells. Plasma cells. Let me see if I can get a classical example. Here's a plasma cell, corkscrew. You can see the nucleus is a cartwheel shape. A lot of cytoplasm associated with another cell in through there, and you can see the different cells. Plasma cell here, and here, and here. There are a host of plasma cells producing antibodies associated with this infection. Very classical plasma cell right there and right there. This is in the stomach. These are parietal cells and chief cells in the stomach. So if we take a look at those cells, another cell we talked about was a monocyte, and a monocyte is a transient cell going to a macrophage. And here in the lungs, we see macrophages where it had gobbled up some debris. So this is a cytoplasm of a macrophage. Here's another one. You can see the nucleus, nucleolus there, and this is stuff it's gobbled up. So here we can see it again. There's a nucleus, and this stuff it has digested in the lungs. So these are air macrophages because this is in the lungs. And if we take a look at this 432 slide, we'll be able to see some of those cells. Here we can see these are the macrophages that we saw there. Macrophages, another one right there, another one right there. So these are air macrophages that are in there, and some are in the tissue as well, as you can see, but these are in the air spaces. So these are different from these cells over here, which produce surfactant. These are macrophages that gobble up the material. Surfactant secreting cells in through here. So these are type 2 pneumocyte and type 1 pneumocyte. Connective tissue. You can see the endothelial cell, nucleus of red blood cells going through there, right adjacent to the airspace. And so we can see those. That's what we're seeing. Those macrophages in through there, which was given rise from the monocytes. Also in the bone marrow, we see the megakaryocytes, multinucleated cell, as opposed to multi-lobes. It's various nuclei and a lot of cytoplasm. And this cytoplasm has a lot of little vesicles in it, so it can literally, these vesicles facilitate it pinching off. So what happens is a megakaryocyte sends its cytoplasm out through there, and the thing pinches off of it. So the nucleus doesn't go. So platelets are non-nucleated, but they do have many functions of cells. Here you can see where they're just streaming there, and the megakaryocyte sitting there, and this is the bloodstream, and so that would be making the platelets. Here you see the megakaryocyte in through there, fat cell in through here, more fat, but you see the megakaryocyte. And if we take a look at this one specimen, again, we can see this one. If we take a look at that, we can see that's a good one right in that area. See the megakaryocyte, there, right next to a blood vessel, another megakaryocyte in through there, more megakaryocytes, more fat cells in through there. And pretty much anywhere you see bone marrow, you're going to see some megakaryocytes in through there. There's one right there that we can see. So bone marrow is a source of platelets, and also it's a source of blood cells, both white blood cells and red blood cells. So here we can see we can't identify all the cells. You can see there, this is in bone marrow. You can see lymphocytes in through there. You can see these orthochromatic erythroblasts. You can see the band cell, lymphocytes, neutrophils that you can see. This is metamyelocytes in through there and there, as we can see. Myelocytes, metamyelocytes versus myelocytes, and the promyelocyte that we can see. So again, we can see a host of different cells in there, orthochromatic, neutrophilic metamyelocytes in through there. You can see the neutrophilic myelocytes in through there, pro-erythrocyte, spherical nucleus for the ortho. Unknown, a lot of smudge cells, we don't know what they are, but the neutrophilic metamyelocyte as you through. Back in the bone marrow, you can see the megakaryocytes in through there, and you can see granulocytes developing with the granules that we saw. Here you can see where a white blood cell, this is a lymphocyte, is squeezing out. These are endothelial cells right in through there, so this is a lumen of blood sinus, and you can see where cells are squeezing out. This is a discontinuous capillary to facilitate cells coming through. And lo and behold, you can see one of those cells squeezing through. This is a white blood cell squeezing out of the extracellular space into the vascular space. We want to thank the various people that contributed original pictures that we showed of the drawings and pictures that we showed today. So this is in New York, and I hope this is useful to you.